We've already seen some measurements and we haven't talked too much about the units. So next we're going to look at the units. In science, when you measure the length of an object, the standard unit that we're going to use is meter, which is abbreviated with a lowercase m. Standard unit for measuring the mass is kilogram, which is kg, lowercase. Time is usually measured in seconds, s. And the temperature is measured in Kelvin, which is a capital K. So these are the usual units, but sometimes, for example, if you're measuring the size of an atom, meter is a much too large unit to use. So we want to be able to scale these up or scale them down. And we're going to scale them by using prefix multipliers. And these prefix multipliers are found in table 2.2. So I try to keep the amount of memorization that you need to a minimum. This is one of the things that you just have to memorize. You're responsible for knowing table 2.2 from capital M to lowercase p. So these two at the top, tera and giga, you don't have to worry about. And the last one, femto, you don't have to worry about. And when I say know this table, you have to know the prefix in both written out form and the symbol. And you need to know what the value of that symbol is. This column shows normal notation, but I recommend that you learn these in scientific notation. This is one of the things that you need to know. You're also going to be responsible for table 5.3, which obviously is found later on, but these are the two big things that you need to memorize. Table 2.2 and table 5.3. So we're going to not only memorize them so you know the values, but more importantly be able to use them. So we can scale up a measurement in grams. Say we measure the mass of an object and it's 4,000 grams. 4,000 would be a lot easier to write using the prefix K for kilo, which stands for 1,000, or in scientific notation, 10 to the third power. So 4,000 grams is exactly the same as 4 kilograms. Same sort of thing if we have a prefix lowercase m. Confusingly, M could stand for meter, but because it's in front of the L, which is liter, this M is milli. So 18 ml stands for 18 milliliters. And milli from the table is 10 to the negative third. So I can replace the lowercase m by putting in 10 to the negative third liters. And notice this is not proper scientific notation. I would have to move the decimal over one place to the left, 1.8 times 10. So I had to move it over one place. This would be 1.8 times 10 to the first, positive first. And then when I multiply that by 10 to the negative third, it's going to give me a final answer of 1.8 times 10 to the negative 2 liters.